In this question, we're given a graph of a function and asked to determine the inverse graphically, then to state the domain and range of both the original function and the inverse. Our function in this case is a set of discrete points, 3 of them to be exact. Well, in order to determine the inverse, what we're going to do is switch the x and y coordinate of each one of those points. So 2, 4 becomes 4, 2, 4, negative 1 becomes negative 1, 4, negative 2, negative 3 becomes negative 3, negative 2. We notice something interesting. What happens here is that the original green function, these 3 points, have each been reflected in the line y equals x to give the new red the inverse. Finally, we're asked to to determine the domain and range of both the original and the inverse. Well, we see the domain of the original, the green points, are negative 2, 2, and 4. And the range of the original is negative 3, 4, negative 1, or ordered more appropriately, negative 3, negative 1, 4. Now let's look at the domain of the inverse, the red points. The domain of the inverse is negative 3, negative 1, 4. And the range of the inverse is negative 2, 2, 4. Well, there's nothing too interesting about that, except when you realize that the domain of the original is the same as the range of the inverse, which makes sense because all we do is switch x and y coordinates. And the range of the original is the domain of the inverse.